Hello everyone and welcome back to part 7 of this tutorial. In this video, we will be creating a movement system for our basketball hoop. Whenever the player reaches a certain score, the hoop will start moving left and right at a constant velocity. Okay, so let's get started. First, we need to go to our uh, hoop class header, and create a projectile movement component. So um, new projectile movement component. Okay, now here we need to give it a property so we can uh, edit it from the blueprint. Now let's create it. Okay, next we need to create it here. First, let's include the header for it. So its header include game framework projectile movement component. And let's create it now. So movement component is equal to create. And let's call it movement component. And what else? We want to set the velocity, and sorry, not the velocity, the projectile gravity scale to 0, so it doesn't have any gravity, so it doesn't fall down. The hoop doesn't fall down. So gravity equals 0. And we want to set auto activate to false, so it doesn't activate by default because we want it to activate at a certain score through the code. Okay, so I think that's it. Now let's go to our game mode, unlimited time game mode. And let's override a function. So virtual void update score. We want to override this function. Let's call the parent. And now, if the current score let's make it here protected, not private. If current score is equal to, let's create a variable here. And let's call it integer. Let's call it target score or whatever. So this score is the score that we want to set whenever the player reaches this score. The hoop will start moving. So you can call it whatever you want. I will call it hoop movement target score. It's a long name, but at least it's you can understand what this is for. Okay, so if it's equal to this score, we need to get the basketball hoop, and we need to call a function that activates the movement. Right now we don't have it, so let's go ahead and create it in our basketball hoop inside of public. Let's call it void activate movement component. So now we check if movement component is valid, and if it's valid, Uh, so for me, I want to have a little random. I want it to be a little randomized. So each time we reach the score, and it needs to start moving, I want it to move in a random direction, either left first or right first. Okay, not always start to right then to left or whatever. I want it to be randomized. So let's go ahead and create an integer for direction equal f math mm, random boolean 1 oops 1 minus 1. So what this does, well, it populates, it gives the direction a value. This value is so we are getting a random boolean, so either true or false randomly. And if it's true, the direction is equal to 1. But if it's false, direction is equal to minus 1. And the minus 1 is for the left, and the 1 is for the right. Okay? Now, I'm not doing this. I'm not doing this because this is a random range between minus 1 and 1. So minus 1, 0, and 1. Okay, we don't want that because we only want either left or right. So that's three values here. Okay, and let's say we got minus 1, it will go to left. And if let's say it got minus 1, it will go to right. However, if it's 0, then it's neither left or right, so it doesn't make sense to have the 0 here. And sometimes the projectile won't activate if it gets 0 as the value. So here it's better to get a random boolean, either true or false, and if it's true, 1, and it's false, minus 1. I hope this makes sense. Now we want to make the velocity, new velocity, is equal to direction times movement component initial speed. Now I don't think we set we didn't set the initial speed, so let's set it now. Movement component initial speed is equal to 80. That's how I want it to be, how fast I want it to be. So now let's apply the velocity. So movement component velocity is equal to factor new velocity and 0. This will make it move from left to right, this velocity, this vector. And we want to activate it. And reset we want to be true. Okay, now let's go here and call the activate movement. So if basketball hoop activates movement component. Great, let's try it now. Okay, first let's go into our game mode. So the hoop is 5, the target is 5, great. Let's try to activate it, to score it, to reach its target. And as you can see, it activated to the left. Now let's try to activate it to the right to see if the randomized direction is working. Yep, so it's random each time. Great. Now, if you notice, the hoop is going out of the screen. It's not detecting the edges of our screen. Right now, it's not detecting the edges, and it's going off of it. We don't want that. We want it to detect our edges. Whenever it reach this edge here, it go back here, and vice versa. It keeps going back and forth. So how do we do it? Well, one way to do it is by creating a class that has two static meshes, and we set the static meshes at the we set them dynamically during runtime uh, at the edges of our screen. So one mesh to the left, one mesh to the right, and whenever the soup overlaps with one of them, it will change the velocity backwards. Okay, so let's go ahead and create the class of type actor, and let's call it screen edges. Okay, let's go to our class here. Let's close everything here. We don't need that. And we need to create few stuff in here. So first, we want to create two static meshes. So view property, that's for the left edge. Now let's create for the right edge. Let's copy paste this. Right. Okay, and we need a function to detect overlaps. So void on begin overlap. Overlapped actor. Okay, and actor, other actor. Mm, okay, now let's create our meshes. Let's first set this to false. We don't need it. Then I want to create a scene component to act as the parent. So scene root component. And root component is equal to the scene root component. Now let's create our meshes. So left edge, okay, and we want to set the collision to overlap all. So set collision profile name overlap all. Mm, we wanted to generate overlap events, and we want to attach it to the root component. Set up attachment. Okay, that's it. So let's go ahead and copy paste this for the right edge. And we want to bind on actor begin overlap. What did you call it? On begin overlap. There it is. Okay, so that's it for now. Now we need, let's compile this first. And we get a crash Maybe because here, I'm not sure. I forgot to change this one. Let's create a blueprint for it. And let's set the edges to be simply cubes. Okay, and here too. Let's change this back to none, to false. And let's make these cubes a little big. And first let's change the color to base. Let's make them bigger. Maybe 10 or 20. So it fills the whole screen. Okay. Now if you drag them in here, okay. Now what do we need to do is to dynamically set these two edges to be at the edges of our screen. So we need a function for that to calculate our screen viewport size and our camera view, and based on that we can get the location of the left edge and the location of the right edge, and we can set them. So let's go ahead and do that. So here in our screen edges, let's create a function called get camera custom edges. Okay, and we want parameters camera component. Mm, we also want a distance float distance, and we want to pass the left edge and the right edge as a as reference. Okay, so f vector left edge or left edge, and f vector right edge. So this function calculates the positions of the left and right center points of the camera's frustum at a specific distance from the camera. Okay, so it's useful for determining boundaries in the word space. Okay, so let's get started. First, we need to declare a struct. This is from Unreal, so minimal view info, and let's call it camera view. So this struct holds detailed data about the camera, like the location of it, the rotation, the aspect ratio, the field of view, and so on. Now we need to fill the struct with our current view settings of the camera that we have. Okay, so to do that, we need to get the camera. Let's include the header for the camera component. What was it? No, it was camera component. Yeah. Okay, so get camera view, and delta time we don't need it here, so we can just set it to 0. And the desired view, the struct, this one here is camera view. Okay, so now this struct here holds information about our camera. Next, we need to extract and compute camera properties. So let's create a float aspect ratio is equal to camera view aspect ratio. Okay, and we need to get the field of view. So also another float field of view underscore y. The y field of view equal camera camera view dot field of view. Okay, and as you can see, it's ignored in orthographic mode, which is fine because our camera is perspective mode. Okay, now we need to calculate the frustum half size at a given distance, this one here, and let's go and create a half height float equal to distance times mass um, mass degrees to radians field of view underscore y times 0.5. Okay, so wait, let me finish before explaining. And another one half width is equal to half height times the aspect ratio. Okay, so these two here calculate how tall, okay, how tall and how wide the view is at the specific distance from the camera. Okay, so visualize it like this. Let's say we are projecting a screen out in front of you. The farther it is, the screen, the bigger it gets. Okay, so this calculates how tall and how wide the camera at this distance. Okay, we need it later on to get the boundaries of the screen. Now we need to get the camera orientation vectors like camera forward vector, the camera right vector only. Okay, so f vector camera forward is equal to camera get forward vector. Oops. Get forward vector and camera right okay. We need these vectors to calculate positions in word space around the camera. So now if you want to get also the upper and the top and bottom boundaries of the camera, we need to get the also get forward. Sorry, we need to get also the get up vector. Now we need to get and store the camera location. Let's do it here. Camera location equal camera view dot location, or like this. This gets the word position of the camera. Now we need to calculate the center point at the given distance that we have here. So let's go ahead and create a vector center point at given distance. It's a long name, but it's clear. So it's camera location plus camera forward vector times the distance. Okay. Now we need to finally uh, find the boundaries of the screen. So let's create a no, not create a vector. We already have it here. So left edge is equal center point at given distance minus the camera right, okay, times the half width. Okay, now the right edge is equal to the same this, but instead of minus, plus. That's the whole function. Now we successfully got the left edge and the right edge position of our camera. Like the edges of where the camera is looking out and the distance from it. Okay, now we need to set the actual static meshes location based on these. So we need to create a new function and let's call it void set edges location. Okay. So now we need a reference to our camera, this camera. So let's go ahead into our game mode interface and create a function that returns the camera actor. So virtual a camera actor get camera actor. Okay, constant equals 0. And here before declare the camera actor class. Okay, now let's go into our parent game mode. Now at the beginning we already got the camera, so that's good. All we have to do now is override this get camera actor. Okay, and we return it, so return camera. Next we go back here and we need to get the game mode interface. So okay, now here game function library first. Let's include it. Functions library. And here game mode interface equal u functions library get game mode interface and get word. So now we are ready to create this function, at least most of it. So a camera actor camera is equal game mode interface get, oh my god, get camera actor. Now we need the camera component, because remember, this is a component, camera component, not the camera actor. So from this camera, we get the camera component. So U camera component is equal to camera get camera get camera component. Camera actor. Now we need two vectors to hold the left edge and right edge toward location. So first one, left boundary or left edge location, and the second one, right edge location. So now we need to call the get camera thrust and edges, and the camera component is camera component. The flow distance. Now let's here's the tricky one. Now I have tried a lot of values, so I reach the proper value for this viewport. Okay, and this value was 100. So let's go for now and set it 100 temporarily, and the vectors here are these ones created. Okay, now let's apply the location. So left edge set toward location, and the location is left edge location, and for the right also. Mm, Now let's compile, and we get an error. Okay, so the problem is here, I guess. Yeah, the problem is here. We need to change the name of these parameters because they override, they are conflicting with this one here. So left edge location, or let's say it left boundary location and right boundary location. Let's copy paste this and paste it here. Left boundary location. Okay, now it should work. Great, awesome. However, I just remembered we did not call this function anywhere. So let's call it in the begin play here. Now let's try, and we get an error at 76. Okay, so the problem is because the camera component is not valid, or maybe the camera is not valid. That's the problem. That's why we always do an if check before we do anything, so we avoid crashes. I think that's because the game, when this actor begins play, this function is being called before the game mode interface, the game mode return our camera actor. So maybe we can give it a little delay to check if that's the problem. Okay, so let's give it a little delay, f timer delay, whatever. Okay, let's set this timer, get timer manager, uh, get timer manager, set timer. Timer is delay, and the function screen edges, set location. Okay, and let's set it after 1 second and repetition loop to false. We don't want it to loop. Let's try now. Just gotta wait for it to launch. Okay, so now the camera, the edges are, let's put them here. And if we start the game, no, sorry, let's start the game here. And as you can see, we set the edges over here and now they are here, which means this function is working, but the location of the Y location is not as intended because it should be here, right? So it should be like this, not behind here. So let's go first. Let's take the actual value here. So it's minus 170, and in our set edges location, we need to create two vectors. So first vector, adjusted left edge location, it's equal to f vector minus 170 and left edge location dot y and 0. Let's make this the same here. Adjusted right edge location. Okay, and we set these here. Now let's try it again. Okay, and as you can see, it's working perfectly fine. Now you may be wondering, well, this is not the boundaries of this screen, of this viewport. Well, that's right, because we set the distance here to be 100 for now temporarily. Later on, we will make it dynamic based on the viewport size, okay? But right now, for demonstration, I just make it 100, and actually 100 fits for this one. So as you can see, it fits perfectly here. Now, we need to make this function here on begin overlap. Okay, so whenever this overlaps with one of them, it will go backwards. It will change its velocity backwards. So just a second. For this to work, we need to get the current ball hoop velocity. So we don't have a hoop interface. Let's go and create one real quick. Let's go way down here and call it hoop interface. And in this interface, we need two functions, one for getting the velocity and one for changing the velocity. Okay, so it's get and set only. Here, Let's create a function of type f virtual f vector get current velocity or get current hoop velocity, and the second one is void set hoop set new hoop velocity equals 0. Now let's go into our hoop, implement this interface. .h hoop interface. Or not override. And I just noticed we need a parameter here. We forgot that. So parameter is a vector, new velocity. Okay, great. Now create this and create this. So here we need to return the movement component velocity. Okay, it's very simple. For the set velocity, um, also movement component set no sorry velocity equal new velocity. That's it. Okay, now here if other actor, if other actor implements the hoop interface, okay, I hoop interface oops, is equal okay if hoop interface a current velocity hoop velocity is equal to hoop interface get current velocity. Now we need to change it. So current hoop velocity is equal to the current hoop velocity times -1. So this will make it go inverse. So if it's going this way to the right, it will go back to the left and vice versa. Then we need to change the so set new hoop velocity, current hoop velocity. That's it. That's all of this. Let's compile. Now we have one issue. Is it's that this hoop now will not um, doesn't have collision overlap collision. It doesn't have direction because it has static. It has block. You see. So let's try one thing. Let's try this, but I don't think it will work. Yeah, it's not working. So what we need to do is to create two box collision here and here, and then it will work. So let's go. We can do it in C++. So let's go here. So ubox component, u property, ubox component left edge collision. Let's copy paste this for the right edge. Let's create them here. Left edge collision. And we need to attach it to the hoop, of course. So set up attachment. Oh, now we need the same for the right. Okay, let's compile now. And inside our hoop blueprint, let's get the one on the left first. So the left is actually here. And let's scale it. Uh, okay, like this. Let's copy this, all of this transform, and make it for the left. Oh, that's what for the right. Okay, doesn't matter. So let's paste this here, and the right, let's make it here. So the left is 52.17. Let's make the right minus 52.17. Right, now let's test it. Okay, as you can see, it's now working as intended, which is awesome. Great, okay. Okay, now we don't want this to be shown, so let's hide them. So here, inside the class, let's make them set actor hidden in game true. Okay, so it needs to be removed then put again, I guess, for it to work. Yeah, okay. Okay, awesome, great. Now let's make it dynamic, and by dynamic I mean it takes the viewport size and calculate the distance, this distance based on this viewport size. Right now it's only a static value 100, but we need to change that. So first we need to get our viewport size, then um, we need to convert this viewport size into a distance, into, no, not convert, but like uh, I don't know, I don't know, but I think you have heard of the rule of three in math. Uh, we need to apply this to get the proper distance for our viewport size. Okay, so now we need, as we said, we need to get the viewport size. So to do that, we need to do it as soon as the game starts. And later on, when we have a main menu or even a splash screen for our game, uh, in the game info instance, in the game instance, uh, it will be initialized as soon as we start this game. Like in the splash screen, that's when the game instance will be initialized. And so the best way to get the viewport size is inside the game instance on the begin play for the game instance. Okay, so it's better than getting it inside when you start playing or in the main menu. It's better to get it as soon as possible, and that's inside the game instance init event. So let's go and create a game instance. Game instance, and let's call it game info instance. That's how I usually call my game instances classes. Game info instance. Okay, great. Now inside this uh, we need to first private override to override the init event. So virtual void init override. So the init here is as soon as the game instance is initialized, this will be called. So it's like kind of the begin play for actors. Okay. We also need a function that fetches the viewport size, and we need a vector to store the viewport size, and this viewport size is a vector 2D. So viewport size, okay. So here, if engine, if engine game viewport, okay, engine game viewport get viewport size, and we store it inside our viewport size variable. Now inside the init, we need to call this function, but however we need to call it a little bit delayed, like half a second or even less, because it takes a few milliseconds for the game to get the viewport size. So like we did before, we need a timer, viewport size timer, or fetch viewport size timer. Now we get word get timer. manager, set timer. Okay, fetch viewport size, and let's try for zero point 0.2 seconds if it works, and set it to false. Okay, that's it for now. Now let's create an interface. Let's call it game instance interface. Okay, and then here virtual void, no, sorry, not void, virtual vector 2D get viewport size. Game instance interface. And then type public, we override it. Just a second, okay. And we return the viewport size. Great. Let's compile this. And let's go to our functions library and create a function that returns similar to this, that returns the game instance interface. So first here, okay, static get game instance interface. Now we need to copy some of this. Let's paste it here and uh, create a uGame instance variable. And it's equal to word get game instance. Instance like this. Okay. Now if no game instance, return null. And if there is a game instance and it implements the game instance interface, okay, we return it. So return cast and the object is game instance. And lastly we return null. Now let's go back to our screen edges and include the game instance interface. And in here before we call the get camera first images, we need to get a game instance interface. So let's create a local variable. Okay, it's equal to u functions library get the game instance interface. Um, where is it? The gameplay. Let's create a variable instead of spamming the get word function. Let's do it just once. So here word equal get word, and here word. Okay, and here also. Okay, great. Next, we need to get the viewport size. So f factor 2d viewport size is equal to game instance interface at viewport size. Now we need to calculate the distance, this distance here, instead of making it 100, constant 100. So float distance is equal. As we said before, we will be using the rule of 3, and since 100 distance 100 works for this viewport, we can work on that. We just need to figure out the viewport here of this okay. So let's just debug it fast. Anywhere here, it doesn't matter. So in here, let's say let's print to string get viewport size. Let's just debug it real quick. Okay, so it's 720 by 972, and since we need the x, this one, not the y, not vertical, we need the horizontal, so it's 720. Okay, so 720, 100 is for 720, right? So let me explain really fast. If 720 has distance of 100, then the viewport, our viewport, which is x, we don't know it, okay, is equal to uh, what? It's equal to x times, so it's x times 100 divided by 720. Then we can get this value here dynamically. Okay, so x here is equal to viewport size dot x times 100 divided by 720. And let's change this to distance. Okay, now it should work, hopefully. Let's compile. And let's start. Now if we okay, so the error was because we forgot to actually set our game info instance as our default game instance in the project settings. So let's go to project settings, maps and modes, and change this to game info instance. Let's try now. Okay, let's try now in the bigger viewport. Well, I gotta say, a bigger viewport is so much harder to score. Oh my god. Oh, okay, I understand it now. So let's wait. And as you can see, it reached the end, and the end here also. Okay, so I think it's working, but let me check something really fast. Not here, here. Hmm, like what happens if we scale this a little bit down, so 0.0 or 0.1, for example. Also, it doesn't matter, it's basically the same. Okay, okay, so yeah, that's it, I suppose. But there's one more thing we need to do. As you can see, we have a delay here, 1 second delay, and we set this up. But right now we need to fix this. We don't want this delay. But first, let's set the actor here to hidden again. Okay. Now let's fix this 1 second delay here. We don't want that. Let's remove this, and instead we need in our game mode. Where is it? Where do we get the camera at? Okay, here. So when we get the camera, we need to notify our screen edges that the camera is found. Okay, and then we call the set locations of the edges function. So we can create a delegate here in our game mode. Where is it? Panel game mode. Here, let's declare uh, the delegate. So declare dynamic underscore multicast underscore delegate. Let's call it on camera fetched. Okay, great. Now f on camera fetched, camera on camera fetched. Okay, and we need to call it here camera fetched on camera fetched. Okay, okay, it's working great. Um, Now we need to assign here. We need to assign in the beginning play a function, which is this function, to this delegate. And We can do that in many ways. First way is we can get a reference to our game mode from here, most probably from our game mode interface. But I'm gonna do it in another way, for learning purposes only. Okay, this way is a little bit harder, but it's nothing if you understand what's happening. So let's go to game mode interface. Let's create a function. Let's call it virtual void assign virtual void assign camera fetched delegate. Okay, so this function will assign a delegate, a function to our camera fetch delegate we created in our game mode, and takes a parameter. The delegate, it will be assigning it. It will assign. So f script delegate. Let's call it delegate. Okay, equals 0. Now here, let's override it. So camera fetched, this one, dot add delegate. It's that simple. Now here in our edges, begin play after we get the game mode interface. We check if we got the game mode interface successfully. And now we need to assign a function, which is this one, to the delegate. So game mode interface assign camera fetched, and it takes f script delegate as a delegate. So let's create it, f script delegate. Let's call it camera delegate. Okay, now camera delegate dot bind u function, and the object is this, and the function is, it takes a f name as the function. So we need to type the function name exactly the way it is. So let's copy paste this here, and now we can pass this as parameter. Okay, that's all. That's everything. Let's compile. And let's unhide it so we can see what's happening. Just a second. You know what? I'm changing this to 1. Okay. Okay. Okay, so there's something. Oh, I guess because this function, yeah, it should be a u function. Let's try now. Hopefully it works. Okay, so it's working, but that's not the right location. I'm not sure why, but I think because the viewport size is not initialized yet. I hope so. If that's the reason, then it's easy. Let's check if that's the reason. So here, here we need to add to string to the screen the values of the viewport size. Okay, to check if the viewport is fetched successfully or not. If it gives us 0, then it's not fetched. So let's go here, gengine, Okay, and the message we want is f string printf um, viewport size dot 0f. No, wait, viewport size x equal this and y equal this. Now here viewport size dot x, viewport size dot y. Um, wait, I forgot the text here. Okay, great. Now it should work. Let's compile. And yeah, you see it's giving us 0 because it doesn't have enough time to fetch them. And that's because, well, we need a main menu screen or even a splash screen or a loading screen even to give time for the game to fetch the viewport size before we access them in the actual game mode, before we play. So we will fix that in the next tutorial. It's enough for this tutorial, it's long enough. We will fix them in the later one, where we will be creating a main menu screen. Okay, so take care, and I know it's been a long tutorial and a pretty tough one, but I hope you understand it. And if you have any questions, let me know in the comment. Until then, don't forget to like and subscribe.